Welcome to this masterclass on embedded C programming. I warmly welcome you to the session. Thanks for coming and thank you for your time. First, I would like to welcome the early comers first. Okay. Uh, Welcome Kalpesh, welcome Sachin, welcome Harina PK, welcome Andy, welcome, and Chandrakant, welcome, PK Creation, welcome, Hemant Kumar, welcome, Ketan, welcome, and Vishnu Priya, welcome, Bhargav Singh, welcome, Deep Shah, welcome, Kavya, and Kapil Panda, welcome, okay, Vinayak, welcome, Yugeshwar, welcome, Arindam Das, welcome, and Shubhadeep, welcome, okay, Atul, welcome, Pushpa, and Tech Bits, Priyanka, Narendra Reddy, and Ishwar, and Bharat, Dinesh, Arulmoli, Shyam Mishra, Gopal Gopi, and Ravindra Parmar. So welcome everyone. So thank you for your time. So thanks for coming. So today, we will be covering up the what is microcontroller, the block diagram of microcontroller, and memory types. Okay. So what is volatile memory and non-volatile memory, and how program is divided into in program we have program sections as well as data sections. Okay, you have to store the program sections on program memory and data sections on data memory. So that we are going to cover up how to store the program sections on program memory and data sections on data memory. And we are going to cover up three architectures: 8051 architecture, and PIC 16F877A architecture, and STM32 architecture. Okay, so 8051 is from Intel, and PIC 16 is from Microchip, from a company called Microchip, and STM32 is from ST Microelectronics, and it uses the ARM architecture. Okay, so ARM is a company, so they get the license from the ARM and they manufacture these chips. Okay, and we are going to cover up the software development flow. So what are all the intermediate files which will be generated when you run the C program? When you give it to an IDE. So we'll be covering up what is IDE like, and what is happening inside the compiler, what is happening inside an assembler, linker, and loader. Okay, and how to download these final files, exe files, hex files to the microcontroller. Okay, and then we'll be covering up what is linker, the importance of linker, and how it works. Okay, and what is native compilation and what is cross compilation, and the IDE download link. I'll be giving the IDE download link, and I'll show you the steps to install, as well as I'll also share the same thing on the Facebook group. Okay, so if you have not joined the Facebook group, please join the Facebook group, so that I'll share you the PPTs on Facebook or the Telegram group, as well as the video for installation for the IDE. Okay, so tomorrow onwards we'll be starting the programming, because these are the fundamentals. Without getting the fundamentals strong, we cannot go for embedded C language. Okay, so let's get to the fundamentals strong, and then from tomorrow onwards we'll be covering up the embedded C program. We will be getting to the program. Okay, so I'll give a short introduction about Pantech and about me, and then we can go for the session. Just take 2 minutes of time. Okay, so Pantech was started in the year 2004. We basically manufacture microcontroller boards, DSP boards, and FPGA boards. We do also manufacture a lot of trainer kits for electronics as well as for electrical engineering. We manufacture sensors like BCA, brain computer interface sensors, and gesture recognition sensors. If you want to know more about our products and services, just log on to our website, pantechsolutions.net. Okay, our vision is to help 10 million students to learn the technology in an easy way. So far, we have trained 2 lakh plus students on YouTube. And this year, we have a target of training around 8 lakh plus students on YouTube. We have a lot of upcoming programs. We have 30 days programs on artificial intelligence, and we have programs on self-driving car, programs on robotics. Okay, so please stay connected on our channel, subscribe to the channel so that you'll get the notification. Sometimes the email may not reach you, it may go to the spam. Subscribe to the channel, like you may get the notification. Okay, so about me, my name is MK Jeevarajan. I completed my bachelor in the year 2002, bachelor degree from the year 2002 from Government College of Engineering, Bagur, and masters from College of Engineering, Guindy from 2004. Basically, I'm from Applied Electronics. So my primary expertise is on microcontrollers, DSPs, and FPGAs. I have worked on various machine learning algorithms and deep learning algorithms. So this session is about sharing my knowledge with you. If you want to connect with me, I will share the LinkedIn link on the chat box. You could send me a connection request. I'm happy to connect and happy to help. Okay. So just give me a moment. Let me share the link. Okay, so I just share the link. Before I proceed, am I audible? Just type yes in the chat box. If I am audible, just type yes in the chat box. Okay, if I'm audible, just type yes in the chat box. Am I audible? Am I audible? I'm waiting for a chat. Just type yes in the chat box. I'm waiting for a chat. If I am audible, just type yes in the chat box. Okay, else no in the chat box. Thank you, Chandra Prakash. Thank you, Pinaki Nandan. Thank you, Ravikant. Thank you, Megha. Thank you, Vidya. Thank you, and uh, Lavanya. Thank you, RTS. Thank you, Manisha. Thank you. Okay, so thank you so much. Okay, let's for the session. Okay. So coming to the announcement, the attendance link will be given at any point of time during the sessions, because most of them, like, they come for the time and they go off. Like, we don't want to issue like the certificates like only for those who attended the sessions completely, because the objective is to learn. Okay. So minimum attendance required to get a free e-certificate is 25 days. You need the attendance of 25 days. So we are keeping the registration open for till this Friday. So if any of the friends wants to join on this session, and they could join till this Friday, okay, and they could attend the session and they could submit the attendance form. And for internship candidates, no need to fill the attendance form. All you have to do is you just watch the video on the portal, and after watching the video on the portal, just give complete and continue on the top. So that will mark the attendance. Okay. So that will mark the attendance. Those who join the session for the internship, like, we have enrolled 3 courses as of now. The embedded C will course will be active from tomorrow. Okay, so for some classes, I'll be using the recorded video streaming for lab classes, or if I'm not able to present it online. And PPT will be shared in PDF format in the Facebook group or in the Telegram group. Okay, please join Facebook group and Telegram group. We'll be also sharing through email, so you could download that. And source code and projects are available download only for the internship candidates, but still you could replicate the same on going through the video. The video will be available for 3 days on YouTube, so you could watch this video for 3 days. After 3 days, we'll be removing this video. And if you have any questions, you can post it on the Facebook group. Okay, so I'll go to the Facebook group at least once in a day, and I'll just reply to the Facebook group. And you, I have pinned a form, Google form on the Telegram group. So you just post the questions there. Definitely, like, I will reply the questions. Okay, so if you have any questions, or if you have any suggestions, you just put a feedback on the Facebook group, or feedback on the you could contact on the Google form, which is on the Telegram group. Okay, so coming to this mindset lesson, so let's start with the mindset lesson. Okay, have shared a video yesterday, like the audio, the radio talk of the strangest secret on the Facebook group. I don't know how many of them has gone through that audio. If anyone has gone through that, just type me in the chat box. If anyone has gone through the audio called strangest secret in the world, okay, which has created a lot of millionaires in the world, has gone through the audio, just type me in the chat box. I want to check if anyone has gone through the audio file. Okay, on the Facebook, I have posted that audio on the Facebook group. I have not sent email. I have posted on the Facebook group as well as on the Telegram group. The strangest secret. Okay, the strangest secret. Joseph is me. Okay, Suraj. Okay, Jay Kumar is also watching. Okay, Saranya, Shantosh. Okay, Lavanya also watched. Okay, so Prashant saying no. Okay, so please do watch if you have time. Please do watch at least once in a once. So that will definitely change your mindset. Okay, so today mindset lesson is about imagination and visualization is more important than knowledge. Okay, any product or anything in this world is created twice. Okay, first the idea was conceived in the mind first it was created in the mind, and then the actual product takes place. For example, the camera what I'm talking to, it was first created in the mind. Okay, and then the actual product takes place. So any product or anything, any, like a Taj Mahal, anything, it was first conceived in the mind, and then the actual product takes place. If you are not conceiving an idea in the mind, then the reality will not happen. So the first thing is you have to conceive the idea in your mind first. So if you conceive the idea in your mind, then the reality will takes place. Okay, so whatever the mind can conceive and believe, it can be achieved. So I want to do as a practice, like you just sketch a picture or on a paper about your ultimate life, or like what kind of life you would like to have, what kind of house you would like to live, what kind of car you would like to drive, and what kind of income you want to earn. So that's just put it on a paper, so that your brain will communicate with the hand, so that neurons will get fired, and your eyes will watch, you will see the sketch, and like it will take its a feedback. Okay, it goes back again to the subconscious mind. So I want to do this activity. Just sketch a picture of what your ultimate life would look like, what kind of lifestyle you want, what kind of income you want, what kind of car you would like to drive, and what kind of home you would like to live. Okay, so this is the mindset activity today, and let's go for the session. So I'll give you a short recap of yesterday day. Like we have covered up yesterday, we have covered up the definition of embedded system. So what is embedded system? What is program? And what are the programs what are the programs available for embedded systems, and the difference between a microprocessor. We have covered up the difference between a microprocessor and a microcontroller and DSP processor, and DSP processor and FPGA, and FPGA and system on chip. We have covered up the differences, and we have covered up when to use digital signal processing in FPGA, and the embedded development lifecycle, and then we have covered up the list of IDEs. These are the things which we have covered up yesterday. So today session is, let's go for the microcontroller, to anatomy of the microcontroller. So are you ready to learn? Just type RTL in the chat box. If you are ready to learn, just type RTL in the chat box. There is no WhatsApp group link, there is only Telegram group link. So please do join the Telegram group. Okay, so Eli is asking for WhatsApp group link. So there is no WhatsApp group link. It's there is only Telegram group link. Are you ready to learn? Just type RTL in the chat box. I'm waiting for your share. Okay. Ravi Kumar, there is no WhatsApp link. There is only Telegram link. Okay. So thank you, Uday Shankar, thank you, and Sujan, thank you, and Ashwin Kumar, thank you, Ramya, thank you, SL. So it's running. Okay. Rahul, thank you. Okay, Lokesh, thank you. Okay, so so what is a microcontroller? So microcontroller, like it's a small computer system which has everything on chip. Like, okay, you have the program memory, you have the data memory, and you have the peripherals. So everything is on chip, system on chip. Okay, everything is on chip. There is no need to interface externally. Like no need to have program memory and data memory externally. But when it comes to the capability, it is limited because it's targeted only for the embedded applications. Okay, so a typical microcontroller looks like this. Okay, you have the processor, the ALU unit, and you have the peripherals. Okay, the peripherals, or you may have the analog to digital converter, and you may have digital to analog converter, and you have timers, UART, USB. Not limited to this, you also have CAN, control area networks, LIN. So there are different peripherals out there, like Ethernet, okay, so HDMI peripheral, and memory controllers. So these peripherals may be it may be more, which is not shown in the slide. Okay, and memories, you have memories. You may have the flash memory or the SRAM. Okay, flash is non-volatile, so SRAM is volatile, and ROM is read-only memory. It's one-time programmable. Okay, and you have electrical erasable PROM, EEPROM. Okay, electrically erased EEPROM, program read-only memory, and you have the clock and you have the bus. So these are the components of a microcontroller. Okay, so coming to the block diagram of a microcontroller, like you have the CPU, you have the program memory, which is non-volatile, data memory, which is volatile. Okay, so on the C program, okay, your C program, you have program sections as well as data sections. Okay, for example, that data sections should be stored on data memory, and the program sections should be stored on program memory. To know what is program sections and data sections, for example, you have the you have a microcontroller, and you are connected to a Bluetooth based home automation. The data which you receive from mobile phone, okay, it should be reside on the data memory, not on the program memory. Okay, so the data from the Bluetooth should reside on the data memory. Okay, so coming to the code memory, like you have mask programmable. It is non-volatile. The code memory is non-volatile. The data memory is volatile. Okay, the program will go off. The data will go off once you reset the processor or once the power is switched off. Whereas the non-volatile, the code memory, the program will be reset like even when you power off. Okay, so there are different types of code memory, like read-only memory. You have mask programmable read-only memory. It's one-time programmable, and you have EEPROM, ultraviolet erasable programmable ROM, okay, which is erased by using UV rays, ultraviolets lights, and then EEPROM. Okay, you have electrically erasable PROM, and you have one-time programmable OTP, and you have flash. So most of the microcontrollers has flash memory. You also have some microcontrollers. You also have the one-time programmable. Okay, so these are the types of code memory. Okay, so is this clear? Is this clear? Like, what is a microcontroller, and what is the block diagram of a microcontroller, the program memory and the data memory? Okay, and you have the code memory and the block diagram and how data is stored on the data memory. Okay, so is this clear till this point? Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. I'll go through your chat. I'm waiting for your chat. Okay. Uh, is that clear? Is that clear? Is that clear? There will be a delay for 10 seconds, okay, for the chat to resume. Thank you, Satish Kumar, thank you, and Patel, thank you, and so I'll go with the majority. Sweta, thank you, Shubham Gupta, thank you, Guru Prasad, thank you, Sri Likita, thank you, Rajnikant, thank you, okay, Rajnikant, thank you, Jeevan Kumar, thank you. So coming to the block diagram of 8051, okay. So if you check the 8051, like 8051, it has the oscillator where you will be providing the clock. Okay, you will be providing the crystal, which will have a range from 4 to 30 megahertz on the XL1 and XL2 pins, and you have 4 I/O ports. Okay, P0 and port 1 and port 2 and port 3. So this architecture, 8051 architecture, was originally from the company called Intel. Okay, so they have the license IP core for the 8051 architecture, and you have the serial port for communication. Serial port communication. You have timers and timer one, and timer one, and you have on-chip RAM. Okay, and you have the flash memory, on-chip ROM and RAM. Okay, and this is for program and this is for data memory, and 4 I/O ports and some multiplex ports, like which can be used as a serial port, interrupts, and the timers. Okay, and you have multiplex ports like for address and data bus. So this is the block diagram of 8051. If you check the block diagram of PIC 16 of 8778, okay, so PIC is from the company called Microchip. It's a proprietary architecture from Microchip itself. Okay, and it has only 35 instructions, and you have analog to digital converter inside this chip. Okay, when you compare with the 8051, like PIC has the A to D converter on chip. So you have A to D converter. You have 5 ports. Okay, you have 5 ports, and the oscillator is 0 to 20 megahertz. Okay. And you have SPI protocol I2C, and USOT is there. Internal, okay, and timers. You have timers and RAM, program memory, and EEPROM. Okay, so this is for PIC. The block diagram is for PIC. And if you check these are the pin details. I'm not going to much more details inside the pin on the architecture. Okay, and coming to the STM32. Okay, if this blue color indicates, this thick blue color indicates the IP core, which is from ARM, where this connectivity and control, analog and system, these are customized by the ST Microelectronics. Okay, they purchased the ARM core from the ARM company. So this uses the Cortex, ARM Cortex M4, which is the core, which is a licensed version. So if you check here, it has internal regulators, internal voltage regulators, and it has the internal RC oscillators. Okay, I'm not sure. You could also check. You could check this block diagram on the Google STM32 block diagram. If it is one, if the thing is not clear for you, if the letters are not clear for you. These are internal oscillators or RC oscillators. So it does not require an external crystal oscillator. Okay, so it could use the internal RC oscillator. So whereas here for 8051, You need to interface oscillator for this for the microcontroller to work, whereas for the STM32 it has an internal RC oscillators, okay, and it has PLL because it is 180 megahertz, okay, the speed is 180 megahertz, whereas for 8051 it is 30 megahertz, 4 to 30 megahertz, okay. So for example, if you're using a 24 megahertz crystal, still you could run the processor at 180 megahertz by using this PLL. Okay, I just repeat. The advantage of going with STM32 is it has an internal RC oscillators, so no need of external oscillators to the microcontroller. Still, it could use this internal oscillators, and it has PLL, which can, even if you give 20 megahertz oscillator to the microcontroller, you could still run it on 180 megahertz. Okay, 180 megahertz. You could achieve the maximum speed by using the PLL, and it has the watchdog timers and connectivity, like you have camera interface, SP interface, CAN interface, USB interface, okay, USART interface, and HDMI and everything. And you have control like PWM control and timers, okay, 32-bit timers and 16-bit timers, and you have 12-bit DAC as well as ADC as well as DAC. Okay, is this clear? Is this clear? So Rahul Jain is asking for it's a C programming session. Yes, it's a C programming session, but without knowing the fundamentals of the microcontroller, this is not a basic C programming. It is an embedded C programming. Without knowing the basics of the embedded, you cannot develop the drivers for this. Okay, so today's session will be of theory part. I will show you how to download the IDE and how to install the software today. From tomorrow onwards, I'm sure that it's pure of program part. Okay, I'm going to start from very basics, like even from the commenter lines. We'll start with how to comment the lines on C program. We'll start with the basics, and we'll go with the we'll go for pointers and structures and much more detail. Okay, how to write drivers for the memory and everything. So so you just get to the fundamentals, because we are developing the C program for the microcontrollers. Okay, without understanding the anatomy of the microcontrollers, like how the microcontroller functions, you cannot write the software for this. Without understanding the hardware, you cannot write the software for that. Okay, so this answer is for Rahul Jain. Okay, so PLL means, like Poppet is asking for PLL. See, PLL is phase lock loop. Okay, the advantage of having the phase PLL is 8051 does not have a PLL, whereas STM32 has a PLL. The advantage of PLL is, for example, you have 20 megahertz crystal to the microcontroller. Okay, but the microcontroller can run up to 180 megahertz speed. So the 180 megahertz mentioned, the 180 megahertz means the speed. Okay, because when you take a personal computers, you'll be comparing with the megahertz, like 22.4 gigahertz. Okay, so gigahertz is the speed which the processor can operate. Whereas if you take 8051, like it is 30 megahertz, it could operate at only 30 megahertz speed. Okay, so you no need to interface 180 megahertz crystal. Like you could interface 24 megahertz crystal to the processor or 50 megahertz crystal to the processor, but still you could use PLL and you could generate 188 megahertz speed. Okay, so you could operate the processor at 180 megahertz speed. So that's the advantage of PLL. Okay, so even oscillators, like it has internal RC oscillators, like no need to give external oscillators. It has internal oscillators. You could use of these internal oscillators and you could regenerate. Okay, so these are the connectivity. This blue color, there are two blue in this block diagram. One is the thick blue and another is the light blue. The thick blue represents the IP core. Okay, the core is from ARM. ARM is a company which does not even manufacture a single chip. Okay, so this STM32 is an integrated circuit. The architecture which is inside this STM32 is an ARM architecture, which was so the ARM architecture was from a company called ARM. Okay, so ARM does not manufacture any chips. They have only the software license. They design the architecture and they license the architecture for various manufacturers. ST Microelectronics is a manufacturer. Texas Instruments is a manufacturer. They purchase the ARM core, LPC2148. If you take LPC2148, that is from NXP. NXP It originally is from Philips actually. Okay, so NXP is a semiconductor, is a manufacturer. So they all purchase this IP core, and they customize their IP core according to their need. Okay, so this blue color, this light blue is the customization done by ST Microelectronics. So they have their own connectivities, like they have 4 I2C, they have 2 CAN, they have 4 SPA, they have camera interface. Okay, they have 4 USART and serial audio interface and HDMI interface and SPDIF. Okay, so is this clear? Is this clear till this point? Just type clear in the chat box. I'll go with the majority. If you want me to repeat, just type repeat in the chat box. But the video will be still there on the channel for 3 days. You could still revisit and you could check. Okay, is that clear? Is that clear? Sweta Reddy is asking a doubt, sir. We give C program is basically in Python. I'll tell you, microcontrollers, the C market, the C program dominates the microcontroller market. Okay, whereas the microprocessor market is dominated by Python. You take Raspberry Pi, you use Python, right, for programming. Jetson Nano, you use Python. Okay, so I'll just go for the next topic. Okay, so this is program code memory. This is the data memory. Okay, so list of ID we are going to use. We are going to use Scale ID and STM32. We are not going to use MPLAB. We are not going for PIC microcontroller. So I'll be using 8051 Scale ID and STM32 Cube IDE. Okay. So what is an IDE? So IDE is an integrated development environment. Okay, which has compilers, which will have an editor window where you could type a C program or a C++ program or an ASM program, which has a compiler, which has an assembler, linker, and loader. Everything put together is an IDE, integrated development environment. Okay, so you have 3 kinds of window. One is the editor window where you could type the C programs, ASM programs, and C++ program, and the console window where you could see the output of the program, and the project window where you could see the file structure. Okay, you could have a single C file, or you could have a multiple C file, or if you could also merge a C program with you could an ASM. Okay, you could have both both C as well as ASM combined together. Okay, that is also possible. So the project window will have the C files, and it will also have the header files. Okay, and it will have the linker files, so that you could go through the C files, you user defined header files, and you could have the view of linker files. That's a project window. And debug and release. Okay, we're coming to the option called debug. When you go for an integrated development environment, you will have an option called debug and release. So the debug stands for when you keep it on, when you keep the ID on the debug settings. Okay, so it generates debug symbols. Okay, generate debug symbols, which is necessary for debugging. So debugging is nothing but to test the program. Like to test the program, you write a software, you want to stop the execution, you want to check the memory values, and you want to check the variables. You could stop the program execution at certain point by using a breakpoint. Okay, by using a breakpoint, you could stop, and you could analyze the variables, you could analyze the memories and everything. So that can be done if you put the ID on debug settings. Okay, once you complete the development, then you could go for the release. So that will optimize. So that will optimize the hex file. So when you keep it on debug window, and if you go and check for the hex file generator, that will be the size will be more. The release window will be the optimized one. Okay, so once you complete all the development, all the software development, you put it on the release mode, and that's for production use, which you give it to the production house to burn the program on the target board. Okay, so memory, apart from this, you also have memory window, register window, and breakpoints and watch points. Okay, so breakpoints is used to stop the execution of the program. Watch points are like you could keep it onto the loop, and you could watch a value at certain point. And debugger is like where debugger is a hardware actually. It's a hardware which connects a microcontroller with the software, with the IDE, and you could keep breakpoints, and you could test the values. Okay, so mostly the debugger and the emulator are same. Okay, so and then you have the programming options. Programming, like sometimes the programmer, you need a flash programmer. For example, Kale, you need Flash Magic or Nuvoton software. The manufacturer will give the flash programmer. Okay, sometimes the programmer will be on inbuilt. If you take Xilinx Platform Studio, like they have the programming options inbuilt. Whereas for Kale, you need separate software for programming, like the Flash Magic or a Nuvoton. If you that depends upon what kind of manufacturer you choose. If you choose a Nuvoton based 8051 IC, you need a Nuvoton software. If you choose an NXP based software, then you can use Flash Magic. Okay. So is this clear? Is the slide is clear? What is an ID is clear? Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Okay. So the attendance will be at the end of the session. Okay. The attendance will be at the end of the session, and it may be at any point of time. Okay. So if I tell that the attendance is end of the session, they will come at the end of the session and they look for the attendance. So the objective is to learn. Okay. So we don't want to issue certificate just for signing up the attendance form. So you'll just learn we can issue a free certificate. That's not a problem. Okay. But you have to learn. The key is to learn. Okay. So thank you so much for Manoj Kumar. Thank you. Pankaj Kumar. Thank you. Varshita. Thank you. So I'll go for the next slide. Okay. Go for the next slide. So coming to the software development flow. Okay. So you have the C++ file. You pass it to the compiler. So the compiler will provide the assembler source. Okay. So the assembler source, you give it to the assembler. Okay. So the assembler will give you the object files. Okay. Will give you the object files. Then the object files, I will cover up the linker later. Okay. So the linker will give you the final ELF file. Okay. So you have the source code. You send it to the preprocessor, which will produce the expanded code, which then you send the compiler that will give you the assembly code, and you send it to the assembler that will produce the object code. Okay, so I'll show you, like, I just go for a compiler called okay, you just type onlinegdb.com. Okay, onlinegdb.com. You just type onlinegdb.com. So this is the source code. Okay, so you first select the language, C language. Okay, you go for settings, you go for extra compiler flags. Okay, and then you set minus hyphen save hyphen temps. Okay, temps. Click OK, and then you run the program. Okay, you just run the program. So so this is the main program. Okay, it has hash include standard input output file. Okay, and int main, so return 0. So we should, so this program, when I set this compiler flags, okay, this main.i is the expanded code for this file. Okay, for the preprocess directives, std standard input output.h. Okay, main.i. So if you check, like if you check this function, like you have printf here. Okay, so this is the printf code. Okay, prototype of the printf, and main.s, this is the assembly code. Okay, this is the assembly code which was generated, and this is the code. This is the object file. Okay, this is the low level language. So this is a high level language. Okay, which is main.i is the expanded code, and main.s is the low level language. Okay, and this is the machine language. Okay, you convert the mnemonics to the machine code. So so this is what happens here, like on the source code. You give the source code. Okay, so the preprocessor give the expanded code. The compiler, like provides the assembly code. Okay, so the assembler provides the object code. Okay, so I give hello.c to the preprocessor. It generates hello.i. Okay, and to the compiler it generates hello.s, and then it generates the hello.obj. Finally it generates hello.exe. The exe file is will be downloaded to the target. Okay, so Is this clear? Is this clear? Is this generation of intermediate files is clear? Like you go for onlinegdb.com and you just set the extra compiler settings extra. You just go for onlinegdb.com, okay, and go for extra compiler flags. Choose the language, okay, hyphen save hyphen temps and run the program. You could see the main.i, main.s, the assembly language, okay, and this main.o, okay. So is this clear? Is this clear? Uh, is this clear till this point? Okay, just type clear in the chat box. I'll go for the next slide. Okay, I'll go for the gold image. Visual MA is asking for hyphen save, not temple. Like just give me a moment. Temps. Okay. Temps. Okay. Hyphen save. This answer is for Visual MA. Okay. Hyphen save hyphen temps. You just go for onlinegdb.com and there will be a default code. Choose the language C. Okay. And give the extra compiler flags. And you could see main.i, which is this, which is the expanded code for this preprocessor directories. I will cover up the preprocessor directories, what is the preprocessor directories in the upcoming sessions. But here you just understand like what is main.i, which is the output of the preprocessor, and main.s, which is the output of the compiler, okay, and main.o is which is the output of the assembler, okay. So assembler, and finally the assembler is given to the linker, will provide an object file, okay, dot object file. The object file is given to the linker, so the linker will give you the final executable file which will be downloaded to the target processor, okay. So is that clear? Just type clear in the chat box. Clear in the chat box. Is that clear? Kiran Kumar is asking for a repeat, okay. Ravi Teja is also asking for repeat. See, it's very simple. You have C++ source file which is given to the compiler. Okay, so before that you have a preprocessor. If you have the header files, so that will convert that to an expanded code. Okay, before you give it to the compilers. So that will be with .i extension. Okay, that will be with .i extension, and you give it to the compiler. You get the assembly code. Okay, you give it to the assembly code. The high level language will be converted to the low level language, the mnemonics. Okay. The assembler will give you the object code with .obj extension, and finally pass to the linker. The linker will give you the final exe file. Okay. So this is what happened. So coming to the linker. Okay. So the linker. When you use an Arduino IDE, okay, whenever you use an Arduino IDE or a Kale or a Kale software, it has a default linker on it. Okay, so it takes the linker file and it gives you the hex file. But when you design an embedded system, okay, when you design an embedded system which has an external memory, which is quite complicated, then definitely like you have to edit the linker. Without writing the linker script, you cannot download the program to the target board. Okay, the target what I'm talking about is a microcontroller or an FPGA or a DSP processor. Okay. So the linker file will have different extensions, like C file. The C file will come up with .c extension, okay, .c extension. Whereas the linker file, it depends upon the manufacturer. Like if you take the Xilinx or the analog devices, they come up with .ldf. The file comes with the extension of .ldf. Whereas for Code Composer Studio, for Texas Instruments, they come up with .cmd, okay. So they come up with their own extensions, and the language will be quite different, okay, but the concept is same, okay. So before we proceed to the linker description file, just type clear the chat box if you are clear till this point, okay. If you want me to repeat, just type repeat in the chat box, okay. Is that clear? So the sample linker file, Prajwal, the sample linker file will be given by the manufacturer. The sample linker file will be given by the manufacturer, but you have to read it if you want to design a complex embedded system design. Okay, you have to. Smith Gupta, have you known Hindi? Smith Gupta, really sorry, like I don't know Hindi. Okay. Okay. Okay, I'll go with the majority because we are running out of time. I'll go with the majority. Okay. .cmd .cmd, like if you choose a linker, if you choose Texas Instruments DSP processor, the linker file, the extension will be with .cmd. Okay. So if you take a C program, okay, if you take a C program, you have the global variables. Okay, you have the global variables, and this is the initialized data and uninitialized data. There are two kinds of global variables. You initialize the values to the global variables. The variables which is used inside the function are called local variables. Okay, so short y equal to 0, that's a local variable, and this is the global variable. Okay, so this is the global variables are called .bss. Okay, any type of IDE, you take Kale, and this is same. A Visual Studio or Xilinx Platform Studio, or the AVR Studio, or the Microchip Studio. Okay, anything is same. The global variable is .bss. If it is initialized values, then it is .cnit. Okay, and this local variable is .stack, and this is called the code, that is .text. Okay, and this is called CIO, standard C input and outputs. Okay, so these are all the sections. These are all the sections of the program. You write a program, the program will have sections. Okay, so you have to you on the linker description file. On the linker description file, you when you design an embedded system design, you have the program memory and you have the data memory. Okay, DDR2 or SDRAM, like that. Program memory is nothing but non-volatile memory. Okay, even when you power off, the program should be there on the flash memory. So DDR2 is volatile memory. Okay, so data memory. So the .text, you have to store it on flash memory. Okay, .cnit, you have to store it on flash memory. .bss and .stack, it has to be stored on DDR2 or any RAM memory, random access memory, which is volatile. Okay, so these are the descriptions, like .text, .switch, .constant, .cnit, .pinit. Okay, .bss, .stacks, .cao. All these are stored in the memory type is initialized, and all these are uninitialized. These are program memory and these are data memory. Okay, so your linker file, will have two descriptions. One is the memory description, the other is called software sections. The memory descriptions will have, this is a sample linker file from Texas Instruments. Okay, so it has the library there on the top. It has the library. You have the stack and heap size. Okay, and you have the memory types of memory, like you have flash memory, DDR memory, any type of memory. You have to list the memories here. This is the starting address of the memory. Okay, this is the starting address of memory which you have to take from the data sheet. Okay, and this length is the size of the memory. For example, you have DDR memory like 64 GB or 4 GB or 2 GB. Okay, whatever it is, so that is the length. Okay, so you have to define this length on the code. So only you take the sample linker file and you just edit this length. This one is same. Okay, this one you have to get the value from the data sheet, and this length you have to edit. Okay, and sections, you have to map the sections, like the IRAM, this BSS is to IRAM. Sometimes you may have 2 or 3 DDR, so you could use the separate DDR will have the separate name. Okay, so you have to allocate the sections to that memory. Okay, you understand? You have to allocate sections to this memory. This code is different, like it is not C language, but they have, every manufacturers they come up with their own type of syntax, but you could grab it within one day. Okay, if you go through the linker script, you could grab the linker script within one day, not even one day, like 1 or 2 hours. If you go through the sample linker script, you could grab the linker script and you could change and you could see the results, but the concept is same. Okay, you have to define the memory with the starting address, and you have to give the length of the memory. So the starting address, it will be on the data sheet. Okay, data sheet of the microcontroller or a DSP processor. And this sections, like you have to define which sections you're going to place on which memory. Okay, it depends upon the it depends upon the type of application. Sometimes we may have SRAM, and sometimes we may have both SRAM and SDRAM. So you can decide which data you are going to place it on SRAM and which data you are going to place it on SDRAM. Okay, is this clear? Is this clear? Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Okay. Okay. I will take a question like Truthokangar. Okay, Truthokangar is asking, sir, how would we use embedded C in robotics? Can we use Arduino IDE? See, I will tell you the difference between the Arduino IDE and the other IDEs. Okay, the Arduino IDE are like everything is inbuilt. Like you could complete the application within a short span of time, but if you want to learn what is happening inside the UART and what is happening inside the SPI protocol, I2C protocol, then it's better to go with starting the scratch. Okay, you go with the manufacturers and you start from the scratch. Okay, so because in Arduino, what happens is everything is an inbuilt C code, which is pre-written codes where you will be using the libraries and you will be calling the libraries and you can finish the project within 30 minutes of time or even 25 minutes of time, short span of time, but you will never learn like how to write a program for the UART, the SPI protocol, I2C protocol, okay, for the device drivers. Okay, when you want to design a custom development board, when you design a custom board with different microcontrollers, then you'll like Arduino IDE will never help. Okay, but if you know the basic of the basic structure of this files and the basic structure of writing the program from scratch, then definitely like you could do the program. Okay. Okay. So the compiler, the IDE and compiler we used the used in this course is STM32 Cube IDE, okay, and Kale 851. So the GCC compiler is online. We are going to use a GCC compiler and onlinegdb.com. We are going to use the host is the machine, okay, is personal computers or laptop, whereas the target is a microcontroller. Okay. So GCC stands for GNU compiler collections. Okay, GNU stands for it is GNU not Unix. The abbreviation of GNU is it's GNU not Unix. Okay, not Unix. Okay, so you download the MinGW compiler, minimalist GNU for Windows if you're using a Windows OS. Okay, so coming to the native compilation, you write the program, okay, and you deploy on the same kind of machine that it is called native compilation. Okay, you write a program on the host machine and you deploy it on the ARM architecture on the target, then it is called cross compilation. Okay, and then it is called cross compilation. Okay, so you could download the IDE. I will share you the IDE link here. Okay, I will share you the presentation on the Facebook group, and the link will be there. So no need to worry. So on the Facebook group, on the Telegram group, on through email. Okay, I will send you on 3 ways. So you could download this IDE here, the Kale IDE from here, the evaluation version. Okay, and you could get the latest link here, the Windows installer. Okay, if you're using Mac OS, you use this version. Okay, Linux, you could use this version. Okay, Windows installer, go with this one, and you could download the MinGW from this link. Okay, I'll show you how to do this. Step 1, you just go to this. I'll just copy this. Okay, just go to this link, and there's an option to install. Okay, download the installer. Okay, there's an option to download the installer. You click download. Once you download, okay, once you download, you have steps. Step 2 is to run this one, and you'll get the command window. You just go open the command window and just type msys2. Okay, just type once you install msys2, go for the command window and type msys2, and you will get this window. Okay, you'll get this window. You just copy and paste this command. Okay, so you just run pacman. It's a package management tool. Okay, pacman -syu. So these steps are there in the are there here in this step 2. It is there in this link itself. Okay, you just follow this pacman-syu. If you face any problems on the installation, you just you take a screenshot and you upload it on the Facebook group. Okay, You upload it on the Facebook group. So you run this command, so things will get installed. So you run this command again to get the tool chain. Once you run and select the option 3, the detailed steps are there in the link. Okay, and you have to set the environmental. Once everything is done, you have to set the environmental variables. Two path you have to set. I'll show you. You just go for environmental variables. Okay, you just go for the properties, system properties, click environmental variables. Okay, and you choose the path here. Choose the path, click edit, and you have to choose. You have to set the path. Okay, you have to set the path for this. Okay, this two path you have to set. So once you set the path, to test whether you have installed correctly, you just come for the command window and just type gcc where gcc. You just type where gcc, like that will give you the installation path of the gcc. Okay, the gcc is for the host. Okay, so I'll share you this PDF file, and I will also share you the video on the Facebook group. Like I'll record a video of how to install and I'll share it on the Facebook group. There is the installation, how to install is also, the instruction is also there in the link which I have given, which I shown, like which I'm going to share. Okay, you could also follow the same thing. Definitely it will work. And if you still face the problem, you just post it on the Facebook group. I will go through your, like I will check for the screenshot and I'll give you a solution. Okay, so today recap, we have covered up what is a microcontroller, the block diagram of microcontroller. Like we have covered up like the memory types, the program data and the code, like the data memory, the program memory and the data memory. And we have covered up the architecture of like 8051 block diagram, just a block diagram of 8051 PIC architecture and the STM32 architecture. And we have covered up the IDE, what is the IDE, and how intermediate files are generated, and what is the software development flow. And we have covered up linker. Okay, we have what is linker and how it works, and how to download the IDE link, and how to what are the steps to install. Okay, so this is the recap today of session today. I will take some. You could use online GDB. Those who don't have PC personal computers, try. I'm not sure online GDB works on mobile phone, but still you could try. I advise you to have a personal computers, or just work it on the. You do the workout on your lab. Okay. So we have. So we just come to the end. Like we have internship. Okay, 30 days internship program. Where you will get the recorded video access and you get support. So those who enroll in the internship, like you also get the VIP Telegram group where you could post the questions, and you will get an invite from the community called hub.warriorsway.in, where you have programs on where you have programs, hackathon sessions, pre-programs on hackathon sessions for 3 hours on IoT and everything. This community will be valid for more than a year. Okay, so you could attend a lot of free sessions on that, and the learning portal is there. Okay, you could download the materials. So all this is available at 750 rupees. If you don't get the link for 750 rupees, let me check. I'll check with my team, and I'll ensure that you get this link by email. And we also have combo offer, which is expiring today. Like we have embedded C programming, embedded system design and IoT, and Internet of Things masterclass, where we cover up 8051 architecture for 5 days, PIC architecture for 5 days, and ARM7 architecture for 5 days, and LPC 4088. Everything comes with a single project. So if you develop this project, no need to, if you're doing a final year, no need to go and purchase a project from. You could do your own project. Okay, and the IoT, like we cover up Amazon Web Service and Microsoft Azure platform, which you could add lot to your resume. Okay, you could add a lot of projects to your resume, and all these values, like with the PCB design masterclass. Okay, you also have, if you enroll today, like you also get the PCB design masterclass, where you could develop your own microcontroller board. Okay, your own microcontroller board, like 8051 board, you could develop. You could do schematics and you could do layout. Okay, and so that we have caught up on PCB design masterclass. So the entire session is for two days, 102 days. Okay. So 90 days, embedded C programming for 30 days, embedded system design and IoT for 30 days, and Internet of Things is for 30 days, and PCB design for 12 days. Okay. So 102 days. It's available for 999 rupees. Okay. It's worth investing the money. And if you found this is not right course for you, we have a refund policy. Within 7 days you get the money refund. Okay. So we also have the job assistance program, where we have around 20 courses. We cover up artificial intelligence, machine learning, deep learning, and Python, and basic computer vision, and data analytics, art programming, okay, and embedded system design, internal IoT, FPGA for 30 days, 27 days, and Arduino 30 days, and MATLAB 30 days, and we have Raspberry Pi 30 days. Embedded. Apart from this, we also have soft skill training like LinkedIn mastery, interview skills, resume building time. Okay, so all this available for 7,999. The validity will be for 2 years. Okay, so the validity will be for 2 years, and the combo which you purchase 999 rupees is for 1 year. Okay, so you have interview questions, job posting, okay, and 2 years validity. So if you wish, you could avail this offer. I'll take the Q&A sessions. You please post the Q&A here. If your question was not answered on this Q&A, you could use Facebook group to post the Q&A. Okay, you just post the Q&A on Facebook group. Definitely, I will give you a reply. Okay. So thank you so much for your time. I'll take a few questions and we'll close the session. Thank you so much. So the certificate will be issued on the last day, on the 30th day. Sometimes it may extend like 2 or 3 days more, because we are generating the certificates for like more than 600 to 700 people. Okay, the certificate will be issued at the end of the session, but you need to have at least 25 days of attendance, and the link will be the attendance link will be shared only on the live session. Okay. Okay, so like, can you have can we have questions, please? Okay. Okay. Can I have questions, please? So if the questions is not answered, like what is the so the Facebook link, I'll give you the Facebook link just a moment. Like I'll share you the Facebook group link. Okay, you just join the Facebook group link. Okay, I've shared. GDB stands for debugger. Okay, GDB stands for debugger. Like someone has the question GDB. GDB stands for debugger. Yes, you could use, if you want to use MPLAB XID, you could use the concept is same. Okay. Ashish Panda, like the PCB design platform is on Cadence, Arcade and Allegro. Okay, Arcade and Allegro. So installation, no need to worry. I'll share you the PPT slide and I'll also give you the link. Just go through the link. Everything is clear on the link. Okay, but still, if you face problems on the installation, you post it on the Facebook group. Definitely, I will help you to get rid of the error. Okay. Yeah. So first, linker, Samitra is asking, could you explain linker description file again? Okay. Shanmitra is asking linker description file. Okay. So the linker description file, like, okay. So your program, your C program, okay, your C program consists of like different sections called .bss sections, .cnit sections, okay, .stack sections, .text sections, .cio sections. consists of different sections. Okay, so this section, it has to be placed on the program sections should be placed on the program memory. So the dot text is program sections. Okay, so these are the dot text. It should be placed on the flash memory. Dot scene, it has to be placed on the flash memory, and BSS data memory. Okay, so you have to divide these sections first, and then on the linker file description file you'll be listing the memories which is available on your embedded system. Like for example, your embedded system can have SRAMs, you can have DDR, or you can have flash memory or DDR2. So it will have sections. Okay, so you just go for the memory map and you find out the address of this flash memory and DDR, the starting address, and the length. Okay, so the length, for example, if the length depends upon the type of DDR you use. Sometimes you will be using 4 GB, sometimes you'll be using 8 GB. So this length will vary. You have to edit this length. Okay, and sections you have to edit. You have to allocate the sections to the memory. Okay, BSS sections to IRAM. So when you write a complex code, like when you design an audio processing applications or video processing applications, then definitely without writing the linker script, it won't work. You will get the memory map error. Okay, you will get the memory error while linking, while you generate the final ELF file, executable linker format file. Okay, ELF file, sometimes ELF file, sometimes hex file. Okay, so the executable linker file format file will not be generated without setting the linker. Okay, without giving the correct configuration to the linker. Okay, so someone is asking for can you post in Telegram? I'll post this PDF on the Telegram. Okay, Nikhil is asking, like, if you are in different domain like system admin, have 9 years of experience, will it make sense if I learn embedded now and switch job? See, I cannot comment on this, like whether it is possible or not possible. Okay, because it's all depend upon your mindset, and it all depends upon the environment where you are. So if you ask me, like anything is possible. Okay, you have to prepare, like you have to change the environment, because I just repeat, a success is all about 80% mindset. Okay, the remaining 20% is a skill set. Okay, get the mindset ready. You just work on your mindset. Okay, definitely, like you could achieve whatever you want. Not only this job, like if you want to change the job, definitely you could change. There's a way. You just work on your mindset. Okay, you check for the peoples who are already succeeded and just follow, just model them. It will work for you. It will work for you. Okay, let me check for the Facebook group link. Sir, if you write a program, then how it will be? Yes, you could use STM32. Okay, Vivek Kumar, I'll check the link. Okay, yesterday itself, like yesterday I got some. I get the same question. I'll check for the link. I'll check with my team. Okay. So, is there any questions? Okay. So thank you so much. Thank you so much for your time. So if you have any questions, you please post it on the Facebook group. Okay. I will go to the Facebook group and I'll reply. Okay. Just allow me 24 hours of time to reply. Okay. So thank you so much for your time. I'll see you on the next class tomorrow. Until then, bye bye. Take care.